Hello everyone, welcome to this short tutorial about my project ResearchGraph AI. In this video I will briefly explain that the project is, how the code is structured, and then I will show you how the platform works from the user interface. ResearchGraph AI is a full-stack research assistant platform. The main idea is to help researchers and students discover relevant papers, understand why papers are recommended, identify skill gaps, and explore the research knowledge graph visually. So instead of only showing list a paper, the system connects paper, topics, skills, users, and recommendation together. This makes the project more than a normal search tool. It works like a small research workspace. The project is built using FastAPI for the backend, React with TypeScript for the frontend, Tailwind CSS for the interface, Neo4j for the knowledge graph database, OpenAlex API for research paper data, sentence transformers for semantic embeddings. So the system combines backend APIs, frontend UI, graph database, and AI-based recommendation logic. Now let me quickly explain the project structure. In the repository, we have two main folders. The first one is the backend folder. This contains the FastAPI application. Inside the backend, I organized the code into modules like routers. This routers fold for API endpoints. This is the routers. This is for API endpoints. Okay, after that, the next folder is services for business logic. The business logic. After that, models for request and response schemas. After that, DB for Neo4j connection and graph schema. This folder for the Neo4j database. After that, data ingestion for OpenAlex integration. After that, this folder for recommendation for scoring and explanation logic. This explanation logic for this folder recommendation. Next, AI for embeddings. After AI, this contains for AI embeddings. After AI, I have folder for ontology for the knowledge ontology structure. The second main folder is the front-end folder. This contains the React and TypeScript application. The front-end is organized into pages and features modules. For example, there are pages for profile, search and import, recommendations, graph explorer, skill gap, advisor. I also created usable UI components such as buttons, cards, metadata, grids, status panels, and page headers. This helped make the interface more consistent and closer to a real SaaS product. The backend logic. The backend starts by connecting to Neo4j. Neo4j stores the knowledge graph. The graph contains nodes such as user profiles, papers, authors, topics, skills, and relationships such as has a skill, written by, belongs to topic, recommended. The system also uses OpenAlex to search and import real research paper. When a paper is imported, the backend normalizes the data, creates paper nodes, author nodes, topic nodes, and store the relationships in new Neo4j. For recommendations, the system uses a multi-single score. The final score is based on semantic similarity, graph centrality, recency. In simple terms, semantic similarity checks how close a paper is to the user's interests. Graph centrality checks how important the paper is in the graph. Recency gives value to newer papers. Then the system explains why each paper was recommended. Running the project. To run the backend, I use cd backend. After that, I will activate the environment. Activate the environments by running the ResearchGraph AI, the knowledge graph database, by using the Neo4j desktop. After that is running, we will come back to the Visual Studio and activate the environment for the backend before we open or running the servers. By using this command line, source for .vimp bin activate. After activate, I will running the server for backend by using ufcorn admin.python. Reload port 8000. After running, we will by using this address for check the backend server is running or not. We will go to the browser and check this address. It's connected. We will come back to the terminal. I will open the new terminal for the front end. I will enter to the front end folder, cd front end. After that, I write this command line by I will write the npm run def. The address for the server for the front end right now is running. Okay, we will check this address to move to the browser. That's it. This is the platform. The server for front end is running right now. This is the main workspace of ResearchGraph AI. This means the same user ID is shared across all pages, so the system can personalize recommendations, skill analysis, graph exploration, and advisor response. Profile page. The first page is the profile page. Here the user can create or update a research profile. The profile includes user ID, name, research interests, skill. This profile is very important because it powers the rest of the platform. After saving the profile, the backend generates an embedding for the interest text and stores the profile in Neo4j. After that, we will go or move to the search and import page. Next we have the search and import page. Here the user can search for research papers using OpenAlex. For example, I can search for a topic like knowledge graph recommender systems, and limit, maybe we can choose here 5 cast limit. The system returns real papers with information such as title, authors, publication year, citation count, topics or concepts. Then you can import selected papers into the research graph, knowledge graph. This step is important because it grows the graph and gives the recommendation and gain more data to work with. The next page is the recommendations page. Here, the system recommends papers for the active user. Each recommendation card shows the paper title. After I will press for the bottom which recommendations belongs on the user. Each recommendation card shows the paper title, final score, semantic similarity, graph centrality, recency, explanation text, evidence fields. The important part here is explainability. The platform does not only say this paper is recommended, it also explains why. For example, it can say that the paper is a good match because it is semantically close to the user's interests, has good graph centrality, and is recent. This makes the recommendation more transparent and trustworthy. The Graph Explorer page visualizes the knowledge graph. Here we can see how users, skills, papers, and topics are connected. The user can filter node types, click on nodes, inspect details, and understand the graph structures visually. This page helps make the knowledge graph more understandable instead of keeping it hidden only inside the database. Like press or click every node and you can extract the data from it. The skill gap page analyzes the user's current skills and compares them with the skills suggested by the recommendations evidence. It shows current skills, missing or recommended skills, suggested next skills, confidence, supporting evidence. This is useful because the platform doesn't only recommend papers, it also helps the users understand what they should learn next. The last page is the advisor page. This is an interactive research advisor. The user can ask questions such as, what should I learn next? Which paper should I start with? Explain my recommendations. Summarize my profile. So, the advisor uses the existing backend context, including the profile, recommendations, and skill gap analysis. So, it's not generic chatbot. It gives guidance based on the user's actual research workspace. So, in this project, I implemented a FastAPI backend, React and TypeScript frontend, Neo4j knowledge graph integration, OpenAlex paper search and import, user profile management, embedding-based semantic similarity, multi-single paper recommendation, explainable recommendation results, scale gap analysis, interactive advisor, graph visualization, a SaaS-style user interface. So the project is not just a simple CRUD application, it's a complete research intelligence workspace. Maybe future work, for example, adding authentication and user accounts, using a real LLM for the advisor, and deployed the project online. These improvements can make the platform closer to a real production SaaS product. That was a quick overview of ResearchGraph AI. The goal of this project is to make research discovery more intelligent, explainable, and useful for learning. If you want to explore the code, project structure, and implementation details, please visit my GitHub account and check the repository. You can find the full project files, README, backend code, frontend code, and setup instructions there. Thank you for watching.